Here we are. This instructional video is a continuation of arithmetic sequences and series. And this time we're going to use the summation notation to find the sum of the series that you will get from this given expression, 3 plus 5i. So we have here written as the sum of I equals 1 to 20 of 3 plus 5i. You know what? Let's talk about the components of the summation notation. Here in this case, we have the sigma with the I is equal to 1. This is known as the index. The I is called the index. And the bottom portion of the sigma, the summation notation, is known as the lower limit. The beginning, the initial part. The lower limit of the summation. And the top over here, 1 to 20, that is the upper limit, the maximum. Okay? So that's why it's a finite. Finite. It's not infinite. And the expression we're going to use to substitute in the first and the second and the third of the sequence is going to be 3 plus 5i. And what we're going to do is, for each time you plug in the first series 1, you plug it in here and evaluate whatever number you get. In this case, 5 times 1 is 5. So 3 plus 5 is, what is that, 8? So 8 is the first of the series. Plus, since the summation, we're adding. The next one is going to be 2. So put a 2 in there. 5 times 2 is 10. And 10 plus a 3 is going to be 13. Plus, one more time, just to show an example, the third is a 3. 3 goes in there. 5 times 3 is 15. Plus a 3 is 18. So what's going on? What's going on with this set of numbers series? Well, they're increasing by 5 and 5. And since the difference is constant, this is called the arithmetic sequences. Okay, so the common difference between each of the series is the 5. And the initial number, a sub 1, is the 8. Now I'm going ahead of myself, but that's how we use the summation notation. It helps you to generate the series of the numbers from the sequence. Let's keep this over here as a reference and try to find the sum of the series from 1 to 20. If we were to substitute it in to 3 plus 5i, what will we get? Plug it in and generate the series of numbers. And like I said, it is 8 plus 13 plus 18 plus, let's do one more time. If we put the fourth one in, 5 times 4 is 20 plus a 3 is 23. And we could go on and go forth. And the difference between each of those numbers is 5. So the initial number, the lower limit that is, that you get from plugging in the 1, the initial number is going to be 8. And the common difference between each of these sequences is going to be the 5. And so we could use the general rule. And remember, the general rule of the arithmetic sequence is written as a sub n is equal to a sub 1 plus n minus 1 times the common difference d. So that's another thing you have to memorize. Not only the components of the summation notation and how to figure out the common difference between the series of numbers and how to recognize the first of the initial. You also have to memorize this arithmetic sequence rule. So let's use that. So a sub n is equal to a sub 1 plus n minus the 1 times the d. A sub 1, we recognize it as being 8 plus n minus the 1 times the common difference is 5. And do the distributive property. So we get 8 plus 5n minus the 5. Combine the like terms with 8 and negative 5, we get 3 plus 5n. So that's the rule. And so, now we have to find out what is the upper limit of this series. What is the upper limit? If you kept putting in 1, 2, 3, and then you put in 20, what will you get? Well, we could kind of figure it out, but we should use this rule instead. So a sub the last number, the upper limit 20, is going to be 3 plus 5 times that position 20. When we evaluate, we get 3 plus 100, so that the sum or the series numbers for the last position, a sub 20, is going to be 103. So the beginning is 8, the last is 103. Now we're going to use the general rule, the sum of finite arithmetic series. Remember that one now. That was S of n is equal to n times a sub 1 plus a sub n divided by 2. So that's another thing you need to memorize. This one, that one, and the components of the summation notation and how to recognize the common difference and the initial set of the number of the series. Alright, a lot to memorize. And so in this case, we have S of n is equal to n times the quantity of a sub 1 plus a sub n divided by 2. And let's move this over here. Now that's what we're trying to find. If you were to add up all these guys, all the way up to the upper limit of 20, what will you get? So the n, in this case, is the 20th, because S of 20, 20th position, times, we know the a sub 1, the initial number is 8, plus, we know what as the last number, a sub n, which is 103. Divide that sum by 2 to find the mean, the average that is. In this case, we could take the denominator 2 and reduce the coefficient 20 by 10. So what we in fact get is the 20th position, the sum of the entire 20 in a series will be 10 times 8 plus 103 is 111, I guess. And so if you took the entire series of 20 numbers, substituting 1, 2, 3 series into this expression, add it up, we get 1110. And that becomes the final answer. Yeah, so now why don't you try number 2. Okay, so you said, well, let's evaluate the series, first few, so we get an idea what the difference is. So you put a 1 in there, 4 times 1. So 11 plus 4 is, of course, 15. Plus the next one, 2 in there. 4 times 2 is 8, plus the 11 is 19. Plus one more, just to be sure. Put a 3 in there. 4 times 3 is 12, plus 11 is 23, and so on and so forth. So are the differences common? Are they constant? Yes, they are. So they are, in fact, recognized as arithmetic series. So the common difference is 4, and the initial number is going to be 15. So we have enough information to draw up a general rule. So a sub n is equal to a sub 1 plus dn minus 1 times the common difference d. The initial number of the series was 15. Plus n minus the 1, and the common difference we recognize as being 4. Do the distributive property. Then we get 15 plus 4n minus the 4. Combine the like terms. The general rule is 15 minus 4 is 11 plus 4n. Alright, so we got our general rule. Now, the last number in the series of 45, if we were to put 45, well, you could actually plug it in here, I guess, huh? And that's what this turns out to be, actually, isn't it? Yeah! Just like before over here. So, let's go ahead and plug it in. So, a sub the 45th position, what would that be? Well, it's 11 plus 4 times the 45. And what do I get? 4 times 45 is going to be 180. And so the 45th position number, 11 plus 180, is going to be 191. Good. So now we could use the sum of finite arithmetic series rule, which is written as S of n is equal to n times a sub 1 plus a sub n divided by 2. And so we're trying to find the sum of the entire series. So the n, in this case, is going to be the 45th, the last one, times the initial number, a sub 1, is going to be 15, plus the last number, the 45th position, is 191, and we're going to take the mean of that. Since 45 is not broken down evenly by 2, I won't do that yet. Instead, let's add the numerators here. 15 plus 191 is 206. 206 divided by 2 times the coefficient 45. Now, half of 206 divided by 2 is 103. And 45 times 103 is going to be 4635. I meant to write 45 over here, by the way. Okay, so if you took the series, the entire 45, the sequences, and add it all together, the sum is going to be 4635. There you have it. Now that we know about the summation notation, and we also know about the sum of the finite arithmetic series, the general rule, let's go a little faster. The lower limit in this case is 1, and the upper limit is 22. And the given expression is 6 minus 3/4 I. So, here we go. Let's go and evaluate sum. So we got 6 minus 3 over 4 times the 1, the initial. The common denominator is 4, so that's like saying 24 minus 3 over 4. And that's going to become 21 over 4. That's the initial, a sub 1. And the last one, because that's all we need to know when we use the sum of the arithmetic series, given as s of n is equal to n times a sub 1 plus a sub n over the 2. That's all we need to know. A sub 1, the initial and the last, divided by 2, and the total number of the upper limit, 22 that is. So to find that one, now we go 6 minus 3 over 4 times the last of the series. The upper limit is 22. So still the common denominator is 4, so that's like saying 24 minus 3 times 22 is 66 over 4. And that's going to become a negative number. It's going to be negative, what is that? 42 over 4. And that's going to be the ace of 22, the last of the series. So now let's plug it in. So S of the total upper limit of 22 is equal to 22nd position times the initial, which is 21 over 4, plus the last, which is negative 42 over 4, divided by 2. The denominator 2 reduces the coefficient 22 11 times. And 21 over 4 plus the negative 42 over 4, that's going to become a negative quotient of 21 over 4. Nothing to simplify, so you multiply across, we get negative, what is that? It's going to be negative 231 over 4. Okay, that's all there is to it. Why don't you try number 4? Alright, so once again, let's find the initial. So we get this time 1 plus 8 times 1, the lower limit. And that's like 8 times 1 is 8, plus the 1 is 9. And that's the initial, a sub 1. And the last is the 34th position. So 1 plus 8 times the 32. And that's going to be 1 plus 256. It will be 257. And that's going to be the last position, 8 to the 34th. So we're going to use the finite arithmetic series, the rule. So we go S of the last upper limit, 34, is equal to 34 times the initial a sub 1, which is 9, plus the last of the series, which is 257, and divided by 2. And again, the denominator 2 reduces the coefficient 34. What's that, 17 times? Evaluate the inside of parentheses. 9 plus 257 is going to be 266 times the coefficient 17. And 266 times the 17, according to my dummy box, I get 4522. There you have it. Is that fast or what?